Assalamu alaikum everyone. This is Usama Ahmed Siddiqui. So we are going to start chapter 1 functions today. This is valid for this syllabus 2020 till 2022. Here I have the learning objectives. You need to know each and everything that is mentioned in this. Okay, so first we are going to understand some terms. The first term we have is function. A function is a binary relationship between the input and the output. It is represented by this is the general notation, not necessarily there should be an F here. Okay, so we are going to discuss the second term, domain. Domain is the input of the function. This is what these are not the actual definitions, but it is just to give you an idea what these things are. The real definition for this will be domain defines the function. Third, range. Range is the output of the function it is also known as the image set. Then we have one-to-one function. Every input maps onto a unique output. I will be explaining you about this in a bit. Fifth term we have is inverse function. Inverse functions are functions. It is a resultant or image function formed by the reflection of the original function by the y is equals to x mirror line line is represented by f inverse of x. Then we have composition of function. A composite function is formed when a function is substituted into another function. This another function could be a different function or the same function. Another function. This is the function formed, so this is a new function. Then we will talk about some notations. First of all, I told you about this. This is function of x. Then we have f inverse of x. This is inverse function of x. Then we have f squared of x. This is the composite function in which we have input the function of f of x into the same function of f of x. This does not mean fx whole square. This does not mean this. This is a composite function. Then we have modulus function. Modulus function of x. So now we are going to discuss some types of functions. Types and you can also say categories. First of all, we have linear function. A function with highest power index of power is the same thing, index of the variable 1. This is an example of linear function x plus 2. The highest power of the variable is 1. This basically it represents a straight line. Then we have quadratic function. A function with highest index of variable 2. This is an example of quadratic function x square plus 3x plus 2. It represents a curve. Then we have a trigonometric function. A function which includes trigonometric ratios. For example, is sin x. This could be cos x, tan x. A lot of this is included in your syllabus in very detail. We will be discussing this in the chapter of trigonometry. Then we have fourth, we have logarithm function. Logarithmic function, a function which includes log. For example, this is a logarithmic function. This is a logarithmic function. Then we have exponential function. A function in which the input is the index of a constant. For example, we have this function k is a constant and the input we take is the index of that constant. So these are the types of function that are included in your syllabus. Now we will be understanding a bit about domain and range in detail. So domain, I told that domain is what defines the function. Domain defines the function. First you need to clarify that domain is the input and range is the output. So for input I will be calling domain and for output I will be calling range. Domain of a function are all those values which give a range of such a number that is part of the set of real numbers. Set of real numbers includes number from negative infinity to positive infinity. These are all the real numbers that lie on the number line. All the decimals and fraction, all of these are included in this. This is a set of real numbers. This is the representation of real numbers in set notation. For example, I have a set, I have a function f of x is 1 over x. For this function, I can input any number and get an output that is a part of this set. But if I input 0 in this function, I will get infinity. So this domain of this function will be the set of real numbers, and I will subtract the 0 from that set. So this is the domain of this function of 1 over x. This means is a part of. Now let's understand about the one-to-one function with respect to domain and range. So for example, I have taken an example. This is the domain, this is the range. Just imagine that this is a set of mothers and this is the set of sons. One son could be a son of only one mother. One mother can be a mother of two sons, but only one son can be a son of one mother. For example, we have a son A, son B, son C. I have mother X, mother Y, mother Z. So this, for one to one, for a function to be one to one, one son should be one mother should have only one son. This is one to one. One mother should have only one son for one to one function. For a function to be one to one, one mother should have one son. This is also written as A is mapped onto X, mapped onto, this is mapping, this is mapping. A is mapped onto X, B is mapped onto Y, B is mapped onto Y, C is mapped onto Z. Now we will consider a new type of function. This is again mothers and this is sons. This includes A, B, C, X, Y, Z. Same domain and range thing. Now the mother X have two sons, son A and son B. This means A and B are brothers and C is son of Z and Y does not have a child. This means A is mapped onto X and B is mapped onto X. This means A and B have a common output. A and B have a common output. This is known as many to one. This is a function this is also a function, but it is not included in your course. The last example I have with this mother and son example, X, Y, Z. When will this relationship become nonsense? This relationship will become nonsense when as the son A will be a son of X and son A will also be a son of Y. This sounds actually nonsense. This cannot happen. This cannot happen. This is one too many. So this is not a function. This is a function, and 1 to 1 is a function. This is not a function. So now let's consider an example in which I will consider a actual function. I have a function x square plus 4. Domain and range. By the way, for this function, if I input 2 and if I input -2, both will give the same output, because the minus sign will get positive in the because of the square. So this is a many to one function, not included in your syllabus. So I should consider a linear function. For this function, if I input 1, 2 and 3, I will get, for input of 1, this is the actual proper method of inputting something into the function. F of 1, for a place of the variable I have input 1, the output I get is the range. F of 2 will 2 plus 2 will give 4, and f of 3 will be 5. So this, for this function, this is a 1 to 1 function. This is a 1 to 1 function because every input is mapped onto a unique output. Every domain is mapped to a unique output, unique range. This was not happening here. Two of the domains were giving the same output of 8. If I input 2 into this function, this will be 2 square plus 4 will give me 8, and f of -2 will be -2 whole squared plus 4. -2 whole square will be 4. 4 plus 4 will be again 8. So this is a many to one function. So for this function, the domain can be all real numbers. X is a set of all real numbers. There won't be any input which gives the output of, that is, first of all, that is imaginary or complex or infinity. The output should not be complex, imaginary, and second of all infinite. Output should not be this. Any input that gives an output that is complex or infinity will not fall part of the domain, which I have showed you for the example of this function behind. So now let's discuss in detail about composite function. Composite function. So I have a function that is h of x is f of g of x. What this means is I have a composite function form that is formed by substituting the function of g of x into the function of f of x. For function of f of x, I have 3x plus 5 upon 2, and for g of x I have x square plus 1. Then g of x becomes, for the function of f of x, I have input the function of g of x. So g of x will come in the place of the input of x. Now I will put the function of g of x here, x square plus 1 plus 5 over 3x plus 3x square plus 3 plus 5 8 over 2 h of x is this. So the new composite function form here is this. So now the domain and range for this function and the domain and range of this function have no relationship with the domain and range of this function. Okay, a new domain and range will be formed for this function, which gives an output that will form a part of real numbers. All those input will give an output of real numbers will be the domain of this function. Okay, so this is how we form composite functions. This is also written as f dot g of x. This is a small circle with a hole in the center. This is f dot g of x. This is equal to this f. In the function of f, I have input the function of g of x. There are some of the properties which you need to learn. F of g of x is not equals to g of f of x. This is not equal. And if I input the inverse of a function into the function, I get the output of x. Now we will be discussing about inverse function. So first of all, I will write down what we have already learned. Inverse function is image function formed by reflection by y is equals to x mirror line. Second, we have that the inverse function and f(x) function are symmetrical about the y is equals to x line. Same thing, which just another way of writing. Third, the domain and range of the original f of x function becomes the range and domain of the f inverse of x function respectively. What does this mean? The domain of the fx function is the range of the f inverse of x function. Why does this happen? This happen because of the we are reflecting it because of the y is equals to x line. So what happens that the input becomes interchanged with the output. The y is basically the f of x. Just another representation of fx is y. Y is a dependent variable. It is also a method of showing the variable that is dependent on to the inputs x. Now we will be forming some inverse function by the equation. Then we will be looking at the graphs and visualizing the relationship. First, I have a function fx is 3x plus 5 upon 2, the same which I took. Find f inverse of x. So there are some basic steps you need to follow. Step 1, place by in place of f of x. Y will be 3x plus 5 upon 2. Same thing I have done. Place y in place of f of x. Then step 2, we have is making x the subject. For making x the subject, you need to leave x on one side of the equation and everything on the other side of the equation. So 2 is getting divided here. We will multiply the whole equation by 2. This 2 and this 2 gets cancelled out, and we get 2y is 3x plus 5, 2y minus 5. It was 5 was positive here, get it negative here, and x becomes 2y minus 5 over 3. Last step you need to do is replace x by y, x by f inverse of x, and y by x. So we had x is 2y minus 5 over 3. I'm going to be doing this step now. This become f inverse of x is 2x minus 5 over 3. I wrote this property in composite function that whenever we input the inverse into the same function we get x. The function I had fx was 3x plus 5 upon 2. Now I will be inputting this function into this function. 3 3x plus 5 upon 2 becomes 3 into 2x minus 5 upon 3 plus 5 upon 2. This 3 and this 3 gets cancelled. 2x minus 5 plus 5 over 2. This 5 get cancelled. We get 2x over 2. Then we get x. So this property is proved here. Now we will be visualizing the relationship between the f inverse graph and f of x graph. So the fx graph is 3x plus 5 divided by 2. This is the fx graph, and the f inverse graph is 2x minus 5 divided by 3. Am I right? No, divided by 3. This is correct now. You can see. Okay, let me add the y is equals to x line as well. Y is equal to x. So you can clearly see that now this red line is the fx graph. This is the mirror line. When we reflect this line about the mirror line, this line is formed. This is the f inverse of x line. You can clearly see then how these are the mirror images of each other. One thing you need to see is that if this is the point on the fx graph that has the coordinate 0, 2.5, when it is reflected we get 2.5, 0. So what actually happens is that the x and y terms are flipped. This happens because we are reflecting it through the y is equals to x mirror line. This is the graph of fx and f inverse x, and you can clearly see the relationship between them through this graph. We will discuss about the modulus graphs. First, I will show you the sketch of this graph. This is a linear function. So this is 3, this is minus 3, this is 2, and this is minus 2. So the graph of x plus 2 will be a straight line because it is a linear function. How it is a linear function? How is it a straight line? This corresponds to the gradient intercept form of the general form of straight line. C is the y-intercept, positive 2. This is the y-axis. This is the x-axis. Positive 2 is the y-intercept, and the gradient is 1. So we have a straight line like this. So this is the graph of f of x. what happens if we apply modulus to it? First we need to understand what this modulus means. Modulus is an operator. What it does, it cancel out the negative sign and give you the answer in positive. In technical terms, what it does, it tells you about the distance of the number, distance of any number, distance of any number from the 0 point on the mirror line. This is what modulus means, and and you already know that distance can never be negative. The modulus tells you the distance of any number from the 0 point on the number line. Any number that is either positive or negative, the distance is always positive. So what it does, it cancel out the negative sign and make anything positive. This is the basic thing that modulus does. So for the function of f of x, these values that correspond to the y-axis are all negative values. So what actually the modulus does to this graph, it reflects the negative part of this graph by the x-axis. So if the reflection seen happens here as well, the x-axis is the mirror line and this is somewhat the sketch of the modulus graph of f of x whole modulus function of x. This is the graph of modulus function of fx of x. It does not reflect the x the positive part because it is already positive, so we do not need to reflect the positive part by the x-axis. Only the negative part that correspond to the negative y values are reflected by the x-axis. Now we will look at a quadratic function, two quadratic functions by the way. This is the y-axis, this is the y-axis, this is the x-axis, this is a curve, and here is a curve. So these are two different types of quadratic curves. One you may know as the sad face and the happy face. So what happens when we apply modulus to these graphs? The basic same thing which happens to that the negative the values which correspond to the negative y-axis are all reflected by the x-axis. So these values and these values all correspond to the negative y-axis, so this is reflected about the x-axis. So this is the graph of modulus of that quadratic function. For this graph, these are the values which correspond to the negative y axis. So these are reflected by the x axis. So this is the graph of modulus of function of a quadratic graph. Now we will consider trigonometric functions. We will learn about sketching their graphs in the chapter of trigonometry. By the way, all of this graph sketching is included in your course. I will be teaching you this in later chapter, in which this is there is a separate subtopic of graph sketching. I will be teaching all of the graph sketching in that subheading. Here I have the sin x. F of x is sin of x. F of x is the cos x. F of x is tan x. There are three more graphs that are included in your syllabus other than these. So what you need to do, you need to remember the shape of these graphs. This is the sine graph. This is the cosine graph, and this is the tangent graph. These dotted lines represent asymptotes. For these x values, the tangent function is undefined. For these x values, the tangent function is undefined. So the graph will never touch these dotted lines. We will be discussing it in detail in the chapter of trigonometry. So now what I am going to do, I am going to apply modulus to it, to all of these. The same basic thing happen. The negative part of the curve that correspond to the negative y values is reflected about the x axis. This is the graph of modulus function of sine of x. This is modulus graph of cos of x. Here this is reflected about the x axis. This is also reflected about the x axis. So these are the final shape of the graph of the modulus function of trigonometric ratios sine, cos, tan. Let's discuss the final learning objective, in which we will find out whether a function have an inverse or not, whether it is a one-to-one function or not, whether it have an inverse or not. So you need to remember two basic tests. There are vertical line test and horizontal line test. So for the vertical line, tell us whether a function is a function, and the horizontal line tell us whether it is a one-to-one function and inverse exist or not. So I am going to make some of the functions, some rough sketches of some graphs here, and then we will perform these horizontal line test and vertical line test on these graphs. So now we will be performing some test on these graphs. This is linear, quadratic, cubic, exponential, circle, elliptical function, hyperbola, log, sine and cos function. So first we are going to do the vertical line test. Vertical line cuts in one place, so this is the function. Vertical line cuts in one place, this is the function. Vertical line cuts in one place, so this is a function. This is a function. Vertical line cuts in two places, so not a function. Vertical line cuts in two places, so not a function. For the hyperbola, if you draw a vertical line here, there will be two points, but if you draw a vertical line as the tangent of this graph, so there will be only one point. So function, it will be a function only if its domain is restricted. What I mean by this, if I restrict the x values till this value, then there won't be a graph above this line. So only this line will appear on the graph. So this will become a function only if the domain is restricted. Here also I have this log function is a function, and finally I have the sine function and the cos function. This is also a function. Now let's go on to the horizontal line test. Horizontal line test tells us if one function is a one-to-one function and inverse function or not. From the previous example in which I took this function x square plus 4, when I was inputting -2 and 2 here, both were giving the output of 8. So this is also shown here that for the same set we will get the same output if we input the same number of same magnitude, we get the same output. So this is not a one-to-one function, This is the one function. This is a one-to-one function. This is a linear function. This is not a one-to-one function. The horizontal line cuts in three places. Yes, the exponential function is a one-to-one function, one-to-one function. This is neither a function, not a one-to-one function. So this is not a one-to-one function. Elliptical function is also not a one-to-one function. Here also the same thing happens with the inverses as well, that only the inverse exists. This function will become one-to-one only if we restrict the domain. So domain restriction needed for one-to-one. You need to remember this. Then this is not one-to-one, this is a one-to-one function. In trigonometry, this is a sine function, and the inverse of sine is cosec. So we get to know that the inverse function of trigonometry function exists. But if we perform the horizontal line test here, the graph cut on two places, the graph show that the inverse should not exist. But in trigonometry, when we study about this function, we get to know that the inverses exist. So there is the same condition arise, that the domain needs to be restricted for one-to-one. The domain needs to be restricted for the inverse function to exist for the trigonometric functions. I am writing it here. Domain needs to be restricted for inverse function of trigonometric ratios to exist. You need to learn this and this. Here also you can see that if I perform the horizontal line test, the horizontal line cut in two places. This means that the inverse of cos does not exist. But when we study trigonometry, when we see that the inverse of cos is secant. These are the short forms. We will study in detail about them in the chapter of trigonometry. So for the inverse of trigonometry ratios to exist, we need to restrict the domain of the function of the trigonometry. So now let's tick the learning outcomes, that whether we have discussed everything or not. So we understand the function, we understand domains, range, and I told you that this range is also known as image set. We understand what are one-to-one function and composition of function and inverse function. We learned notations for that. I told you these are trigonometric function. This is the log function. I will tell you about this LG. What this LG means, I wrote LOG, but what this LG means, I will be telling you about this in the chapter of log and exponentials. This is the domain of this LG function. This is the restriction of the domain which I was talking about. In the domain is restricted to be all values that are positive. No negative value can be input in this function. Then we learned f inverse and f square x. This is not f square x, this is a composite function. Then we understand the relationship between fx and the modulus graph, where the graphs were linear, trigonometric, or quadratic. I drew the graph of linear. I drew graph of three trigonometric ratios, sine, cos and tan, and I drew uh, the graph of two types of quadratics, in which the one was happy phase and the one was the sad phase one. Explain in words why a function is a function or not, and why does not have an inverse. This I told you by the help of the vertical line and the horizontal line test, and I also told you about this by the son and mother example. So we have done this as well, we done this as well. Then we find the inverse of one-to-one function. I told you about the step of these, the three basic steps you need to follow, and we formed the function of composite function, which was h of x, which we formed. Then I show you the relationship of the function and its inverse on the graph. I will be teaching you the sketching of this graph in a later chapter. So this is all for the chapter of the functions. I will be uploading soon the next chapter. Take care.